Let us solve some more exercises about section 5.7, which is about the inverse trigonometric functions. So here, example 7 says, find the exact value of cosine tan inverse 5 over 12. The idea is always to call tan inverse or any inverse trigonometric function, you call it theta or y. Okay, I will call it y. So let y be tan inverse 5 over 12. The reason behind that, so we can use the definition. So what the definition says, it says that tan y would be 5 over 12. Now, from here, we have two information, and please pay attention to this. First, we know that y is in the domain of tan, and the domain of tan that we chose is from negative pi over 2 to pi over 2. So that's the first information. And from negative pi over 2 to pi over 2 is here, quadrant 1 and quadrant 4. But now, the second information, tan is positive. And tan is positive means y is in the first quadrant. So this is the angle y. What is tan y? Tan y is 5 over 12. All right. What is tan, if you remember? Tan is opposite, so the opposite is 5 over the adjacent. The adjacent is 12. So we can draw this triangle, and we know tan y, opposite over adjacent, so the opposite is 5, adjacent is 12. What do we need to find? We need to find cosine tan inverse 5 over 12. And cosine tan inverse 5 over 12 is now equal to cosine y, because tan inverse 5 over 12, we call it y. And y is this angle. So how to find cosine this angle? Adjacent over hypotenuse. So 12 over hypotenuse. So you only need to find the hypotenuse. So if we call it r, then we know that r is square root of 12 square plus 5 square from Pythagorean theorem. So the answer is 13. So cosine y is 12 over 13. This is the way you use to solve any similar questions. So for example, sine tan inverse, do the same exactly. Call tan inverse y and then tan y and determine whether this would be in the first or the fourth. This is positive, it would be exactly like this question. Now let us solve another one. Similarly, same steps. What is the first step? Let y equals whatever inverse, the inverse trigonometric function in the question. Good. And then you use the definition. You write sine y equals negative 1 over 3. In the midterm, if a question comes like this, there are points for each step. If you write this step, you get 1 out of 4, for example. Each step, okay, is important. So now y is the domain of sine. What is the domain of sine we chose? If you remember, it's from negative pi over 2 to pi over 2. Again, this is the first or the fourth quadrant. But sine is negative. Sine is negative means this is the angle y. Okay, so this is the angle y. I can draw the triangle of this angle. What do we have? Sine y is negative 1 over 3. What is the sine? It is the opposite over the hypotenuse. So the opposite of y is -1. And this must be negative because y below the x-axis, so this is negative, true. And the hypotenuse is 3. So we need to find the adjacent side to y, this one. Let us call it, for example, x. Okay, let us call it x. Now, how to find x using Pythagorean theorem? X is square root of 9, 3 square minus 1 square, or -1 square. So it would be 9 minus 1, 8, or 2 square root of 2. Now, what do we need to find? We need cotan sine inverse of -1 over 3. But sine inverse -1 over 3 is y. And this is the triangle of y. So we find cotan y from this triangle. What is the definition of cotan y? Cotan y is adjacent over opposite because it is the reciprocal of tan. What is the adjacent to y? X. And x is 2 square root of 2 over the opposite side. And the opposite side is -1. So the answer is -2 square root of 2. That's the answer. Of course, if you put it in the calculator, it will give you the same answer, but the exam, you have to show your work like this. Again, this is the same question, similarly, but instead of cotan, he is asking about cosine. So please do it at home. This is also similar to the previous one. And look to the question. Use a sketch. So where is the sketch? This is the sketch. So if there is a question like this, there will be 1 or 2 points for the sketch. If you don't graph the sketch, you lose points. Okay, so you need a sketch and you need to find the exact value. So approximation is not accepted. Let us do this one. Sine cosine inverse square root of 2 over 2. What is the first step? Same. Y equals cosine inverse square root of 2 over 2. Implies that what? Cosine y is square root of 2 over 2. So we need to draw a sketch for the angle y. So first, where is y? It is in the domain of cosine. And domain of cosine is from 0 to pi. Where is 0 to pi? It is here. So this angle either in the first quadrant or in the second quadrant. But cosine y is positive. So this angle has to be in the first quadrant. So the angle y is an angle in the first quadrant. And this is the triangle of y. What is the information we know? We know that cosine y equals adjacent over hypotenuse. Okay. If you take it like this, it is up to you. But I know that this is indeed 1 over square root of 2. So it was 1 over square root of 2, and then he rationalized the denominator. I'll take it as 1 over square root of 2. If you want to take it square root of 2 over 2, it is not a problem. You can do that, but it is easier if you take it 1 over square root of 2. So the adjacent is 1, and the hypotenuse is square root of 2. Now, if you find this this side, which let us call it y, or let us call it b. Okay, let us call it just b. You can find it similarly using Pythagorean theorem, or you can remember that we have a triangle for 45, 45, and that triangle has 1 square root of 2. In fact, this must be 1. So now what do we need? We need sine cosine inverse square root of 2 over 2. But this is equal to sine, and cosine inverse square root of 2 over 2 is just y. So now we need to find sine y. What is sine this angle? Opposite over hypotenuse. So it is 1 over square root of 2. Or if you rationalize the denominator, it's square root of 2 over 2. 2. So that's the answer. I leave this for you, or let me do it for you. Okay, let me also do this one. Again, same steps. Let y equals cosine inverse negative square root of 3 over 2. This is f and only f. Cosine y equals negative square root of 3 over 2. Y in the domain of cosine. So y is from 0 to pi. Let us sketch the graph. Now, either this angle y in the first quadrant or in the second quadrant, but cosine is negative. So the angle y is in the second quadrant, and this angle is the reference angle of y, okay? The reference angle of y. And the six trigonometric functions of y would be equal to plus or minus the six trigonometric functions of the reference angle y prime. All right. Cosine is negative square root of 3 over 2. We have seen that cosine is adjacent over hypotenuse. So adjacent is negative square root of 3. And hypotenuse is 2. Now how to find this one? B. Also, if you remember the triangle 30, 60, you know that we have 2 square root of 3 and 1. So 1 is the length of this side. Okay, now what do we need to find? We need cosecant, cosine inverse, but cosine inverse is y. So we need cosecant y. What is cosecant y equals cosecant y prime? Okay, so what is cosecant y? It is the opposite of sine. So it is hypotenuse, which is 2 over opposite, which is 1. So cosecant of y would be 2, and cosecant cosine inverse negative square root of 3 over 2 is just 2, because cosecant is the reciprocal of sine. I leave this for you. Let us now solve example 9. Here he says x is positive from 0 to 1. Write cosine sine inverse x as an algebraic expression in x. Exactly the same steps. We call y sine inverse x. Any inverse trigonometric function, you have to call it y directly, immediately. Why? To use the definition. What is the definition? Sine y is x. Okay. Now I know that y is the domain of sine, so it is from negative pi over 2 to pi over 2. So either in the first quadrant or in the fourth quadrant. Now he said that x is from 0 to 1. So x is positive. So sine y is greater than 0. So y has to be in the first quadrant. All right. What do we know? We know sine y, which is x. What is sine? Sine is opposite over hypotenuse. Okay. And what is this? This is x over 1. All right. Here in this quadrant, everything is positive. So the opposite side would be x. The opposite side of y would be x. And the hypotenuse would be 1. Now, how to find this side? Okay, we use Pythagorean theorem. 1 is the hypotenuse, so 1 square minus x square. So it is in fact 1 minus x square. Good. So the length of this side is square root of 1 minus x square. Now what do we need? We need cosine sine inverse x, but sine inverse is y. So what is cosine this angle? Adjacent over hypotenuse, so 1 minus x square over 1, or just square roots of 1 minus x square. This is a similar question. Please do it exactly the same, and x is positive. Let us do this one. Use a right triangle to write each expression as an algebraic expression. This is called an algebraic expression. Okay, this is an algebraic expression in X. This is what he means by he says algebraic expression. Assume that X is positive and that the given inverse trigonometric function is defined for the expression in X. So what to do? Again, let y equals sine inverse 2x. Any inverse trigonometric function, you just call it y. Good. This is f and only f. What? Use the definition. Sine y equals what? 2x. And he said that x is positive. So this is positive. So sine is positive. And y, again, between negative pi over 2 and pi over 2. So either in the first or the fourth quadrant. But sine is positive, so it must be in the first quadrant. So this is the angle y, and this is the triangle of y. What do we know? We know sine. Okay, what is sine? Sine is the opposite over hypotenuse, and this is 2x over 1. So the opposite is 2x, and the hypotenuse is 1. How to find this one? As we did just a minute ago, 1 minus 4x squared. So this is 1 minus 4x squared, the adjacent side. And now we have the triangle of y. So let him ask any question he likes. So cosine sine inverse 2x is just cosine y. And what is cosine y? Square root of 1 minus 4x squared over 1. Or we just write it square root of 1 minus 4x squared. Please try to do this one. Similarly, don't afraid, it would be the same exactly. Okay, and this is also sine inverse. These are the last two questions. Let me choose one of them and solve it for you. Okay, I'll do this one. Let me do this one. Let same steps, y equals sine inverse x over square root of x squared plus 4. This is f and only f. Sine y is x over square root of x squared plus 4. And he said that x is positive and the square root is positive. So sine is positive and y belongs to negative pi over 2 to pi over 2. So either we are in the first quadrant or in the fourth quadrant. Since sine is positive, we are in the first quadrant, and this is the angle y. Now what is sine? Sine is opposite over hypotenuse. Opposite is x. Hypotenuse is square root of x squared plus 4. We need to find the adjacent. How do we find the adjacent? It's square root of the hypotenuse square, which is x squared plus 4 minus x squared. X squared cancels with x squared, and you get square root of 4, and that's 2. So this must be 2. So the adjacent is 2. Now what do we need to find? We need secant sine inverse. And this one, we called it y. So we need secant y. And this is the angle y. What is secant? Secant is the opposite of cosine. And cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. What is the hypotenuse? Square root of x squared plus 4 over the adjacent, which is 2. This is the end of section 5.7. And we meet, inshallah, in the next chapter.